What does a microwave and an X-ray have in common? Well, both are part of the electromagnetic spectrum. They both have this extremely long, complicated word, which is actually made up of two words, electro and magnetic. So the electromagnetic spectrum is basically organizing all of the waves that when we organize all the possible electromagnetic waves by wavelength. So what's an electromagnetic wave first? So we know that we have two fields, the electric field, and we have the magnetic field. We also have other fields such as gravity, but these are just two of them. So this is the magnetic field, magnetic. So we have the electric field and the magnetic field. Now, what's interesting about the relationship between these two is a change in the electric field, so delta E, causes a change. So this is causes a change in the magnetic field, and vice versa. So a change in the magnetic field causes a change in the electric field. So what that means is, let's say the electric field changes like this. This is the electric field. The magnetic field, as the electric field changes, is also going to cause a change, like this. Now, at some point, the electric field is going to stop changing, and it's just going to stay constant, and that's going to cause the magnetic field to change, because, after all, moving from something to nothing is a change. So that causes the magnetic field to actually come back and starts to change. And then we repeat the cycle again, this time the electric field moving back down. The change of the electric field causes the change of the magnetic, and it just keeps going back and forth between electric, magnetic, and that is what creates a wave of electromagnetic properties. Electromagnetic wave. Now, how does this relate back to our X-rays here and our microwave? Well, these are both electromagnetic waves, and when we talk about the electromagnetic spectrum, remember I said it's when we organize all of the electromagnetic waves by wavelength, we find these two in there. So what does the electromagnetic spectrum look like? Well, we start off the longest wavelength, so this is the longest, lambda, so this is when lambda is the longest, and this is the shortest lambda, So the longest lambda, just going to give you this, and we'll discuss each one individually. So this is the radio waves. Then comes microwaves. Then infrared waves. Visible. Then comes ultraviolet. Then comes X-ray. And lastly, the most powerful wave is gamma ray. So this is the shortest wavelength. This is the longest wavelength. However, this also has the lowest frequency. This has the lowest frequency. And this has the highest frequency. So let's talk about each one of these individually. Radio waves. Well, we see those in our AM, FM radio. Microwaves, other than seeing them in our microwave ovens, we see them actually, they also occur naturally. Infrared, you might have noticed. Oh, so this is microwave. Infrared, you might notice many times it's in our remotes. This is in our TV remotes. There are also infrared sensors. And there's also certain types of cameras which can only see infrared light, which are very special cameras. We cannot see what's projected by them, though, so they're usually for other purposes. I'm going to skip visible. We'll come back to that in a little bit. Ultraviolet, UV rays emitted by the sun, they give you a sunburn or suntan. X-rays used for your body to, analyze whether you have broken bones or other broken things. And then gamma rays are very high-powered rays. We don't really see them that much, but they see them a lot in space. So that's a very high energy, very dangerous wave, actually. So it's dangerous and high energy. Now, I said I'm going to come back to the visible light spectrum. That's because the visible light spectrum has its own special spectrum. You might have heard this famous person's name. His name is Roy G. Biv. This is actually the visible light spectrum. This stands for red, orange, yellow, green, blue, indigo, and violet. The visible light spectrum. So red, you can see, is actually further towards this side of the spectrum, which is actually less amount of energy. And violet is actually very close to ultraviolet and is on this side, so violet has the most energy. So that's how it works. With red, the lowest frequency, the longest wave, and violet, the shortest frequency and the shortest wavelength. So that's how the visible light spectrum works. There's also a unique formula called energy E is equal to nu. That's very similar to mu, but it's a little bit different. And then it's multiplied by H. And basically what this means is the frequency. And this is Planck's constant. This is very much an advanced concept here. So this is actually not really that key concept yet at this level. Now, when you get more into advanced theoretical physics, it becomes more important, and it's actually a very essential formula. But for the sake of this video, we're just focusing on the electromagnetic spectrum. So remember that we're basically organizing light. We're organizing light, putting in the context of all these other electromagnetic waves.